ohm meter. The ohm meter is used to test continuity and measure the resistance of a circuit or component. Both probes should be in the left and center ohm and common ports. The meter will default to the auto range setting, and it should remain here, except in certain specific cases. If you're in the manual range mode and wish to return to auto, simply hold the range button for 3 to 4 seconds, and the meter will readjust. There are several cautions when trying to use the ohm meter to diagnose a fault. There is no danger to you or the meter, but you can miss a diagnosis and cause yourself great frustration if you misuse the meter. 1. The circuit must be completely isolated or disconnected from all other circuits, systems, or components for the reading to be valid. This can be difficult to do. 2. The ohm function only uses approximately 3 volts to measure. In large vehicles, this can be a problem. 3. The ohm meter is not as accurate on low-resistance circuits. When searching for continuity in large conductors, a significant fault can be invisible. Voltage drop will often be a better choice. 4. The circuit being tested must be de-energized. There is no danger to you or the meter, but the reading will be incorrect. Note: in most systems, a correctly functioning component will nearly always be less than 400 ohms. A high reading of kilo or mega ohms will seldom be correct.
The ESI 485 has a standard ohm meter that goes up to 60 mega ohms or 60 million ohms. When you use the ohm meter, you have to be very careful that you go to the trouble to take the time to disconnect, unhook, and isolate everything in the circuit before you attempt to make an ohm reading if you're planning on ohming something out in a vehicle or in industry. Using the ohm meter on an isolated component in your hand is no problem. In fact, that's what it's best at. So when you're using the ohm meter, if you're going to be testing a component in your hand, it's important to remember a couple of things. Keep your hands out of the reading. It happens very often that the component will be open, the component will be failed. And if the component is failed with no continuity, if you put your hands in the circuit and you're testing with your hands touching the probes, number one, this is a little dangerous. You don't want to do that because you don't want to be in the habit of doing that, especially in high voltage environments. But secondly, it's going to give you a false indication that the component may actually be functional. And if you don't know what the meter, if you don't know what the ohm value for the component is before you start, then it's going to be pretty tough to know whether the component is any good or not. So when you're using the ohm meter, if it's going to be in the circuit, you must isolate everything in the system, which is a long process, complicated, that requires a lot of effort on your part. And if you think about what the manufacturer's instructions tell us, they almost always will include steps like go to this pin, open this connector, do this, jump this, go here, and then read the ohms or read the resistance between this pin and this pin. Well, what they're doing is they're walking you through the circuit isolation process. And the fact that they include that in there, number one, makes it obvious that it's important. So if you're going to be reading ohms, you have to isolate the circuit. The second thing that's interesting about how they put it in there, it takes a lot of time. If you've ever tried to follow these flow charts, you know that they can be really, really tedious and really, really involved. And that proves right there that the process of getting the circuit isolated for testing is complicated, difficult, and a pain in the rear. So that's one of the reasons that I prefer not to use the ohm meter as often as some people do. So the ohm meter is a good tool for what it's designed for, but it is not really good for most of the things people try to use it for. Okay, now listen, the ohm, diode, continuity buzzer, and capacitor check function are all here on the same setting. And to move between them, you have to hit the select button. The select button is going to be your friend on this meter. So you hit select once and you move from ohms to diode check. This is a diode. and you hit it again, you go to continuity buzzer. It's not a particularly loud buzzer, but it's there. Okay, and there's something about the continuity buzzer I'll tell you in a second. And then the last one is capacitor check. And you know it's in capacitor because it says nanofarads. The letter F, little letter N, and F show up. And there's a capacitor. Okay, so let me run through this, and I'll give you the details on how this set of functions work. So obviously, meter's off, turn it on, and the first thing you have is ohms. Okay, well, the ohm meter is a good meter for what it's good for, but it doesn't work very well for diagnostics because you have to unhook everything. It doesn't have a lot of horsepower. It's only got 3 volts. So how do you read it? Well, in this case, this is a 150 ohm resistor, brown, green, brown, and it shows 150 ohms. Okay, so if we showed you a different resistor, it would read in kilo ohms or mega ohms. And for example, here's a, let me see, yellow, purple, yellow is 470, 47, I don't know, 47, I think it's 470,000. I'm not sure. Let me find out here. Yeah, oops, 400, don't ever be afraid of this. Don't put your hands in here if it's a big number. Okay, I'm going to show you something in a minute. Okay, so there's the 465K or 470,000. Yellow, purple, yellow is 470. The second yellow, or the third yellow, means add 4 zeros. Now watch what happens if I short across this. See, I get a different number? Okay, well that's because this is a big resistor, and my body has some resistance. So keep your hands out of the ohm meter. Whatever you do, keep your hands out of the ohm meter because it'll mess up the reading. The worst thing that happens is the correct reading is OL, but your hands get in there and you think something's going on. Okay? So if your hand's in the mix, you got a problem. So keep your hands out of the ohm meter. Okay?